We've all experienced this happen before. A flash sale drops and you add the last unit to your cart. You check out and 5 minutes later you get an email saying, sorry, this item is out of stock. We are refunding you. That's not a random glitch, that's a race condition, and today I'm going to design a system that has to prevent exactly that using Mara AI. So here's the actual problem, stripped down to its simplest form. Say there's exactly 1 unit of an item left in stock. Two people click buy at almost the exact same millisecond. Both requests hit the server. Both requests check the database and see that stock is greater than 0 or it is 1, but neither one has updated it yet. Both requests think it's fine to proceed. Both get charged. Now you've sold one item to two people. Here are user A and user B. That's a race condition. Two operations racing each other, and the outcome depends on timing instead of logic. The naive way people usually think of first, just check the stock before selling, doesn't actually work because the check and the actual sale aren't a single step. There's a gap between I looked at the number and I updated the number, and that gap is exactly where the bug lives. So there are two broad strategies to close that gap. First is pessimistic locking. So what we do here is that you log the row the moment someone starts trying to buy it. So nobody else can even read or touch it until the first transaction finishes. It is simple and safe, but a lot of people are hitting the same item at once because it's a flash sale and everyone just waits in line one at a time. So it locks the row, everyone else waits in line. It is very simple and safe, but it is very slow under heavy contention, and that usually happens in a flash sale. The other is optimistic locking. We let everyone try at once, but we attach a version number or a condition to the update, like only decrement stock if it is still greater than 0, in the same atomic operation as the decrement itself. If two requests race, only one wins the atomic update and the other one gets sold. Uh, and we can show a message like, sorry, that didn't go through, and try again, instead of both succeeding. So the losers get try again. It handles busy, bursty traffic very well, and it is better fit for flash sales. So most real systems lean optimistic for this exact problem because flash sales are bursty. Thousands of people hitting the same item in the same second and locking everyone into a single file line would make the whole page feel broken. Let's see which one Mara AI will pick and whether it will even consider both. So I guess this is going to use some kind of atomic decrement operation directly at the database level, something like update stock set quantity equals quantity minus 1. Basically, we are decreasing the quantity by 1, where quantity is greater than 0, as one single statement rather than reading the value first and writing it back separately. But what I'm unsure about is whether it adds on top of that really extreme contention, like a queue or a waiting room, since 50,000 people might hit the same item, and we're going to get a very brutal load the database. So let's move on to our AI and give it the prompt for designing the system. Now let's generate the blueprint and look at the assumptions and requirements. So these are the assumptions. This one is fine, 10 million users per day. And I would like one more assumption. It already generated a good constraint for 50,000 concurrent users during flash sales. and read heavy with bursty concurrent writes during flash sales. So this part was already covered by the AI. Now let's confirm the assumptions. Here are the functional requirements. The system must accurately maintain the current stock quality for each product or quantity. It must decrement a product's quantity when it's purchased or overselling, right? Correctly process multiple concurrent requests to update the stock quantity of a single product upon, yeah, that's fine. The system must update 10 million, yeah, right, right. So these all look good. Now let's try to see that if it chooses pessimistic or optimistic, which is the main goal. So let it generate. So here is what Mara AI has generated for us. I will straight away go to approach details to find out how we are using it. So I'll give it a read. Okay, this is way more specific than I expected. So the actual strategy here is Redis is the source of truth during the sale, not the database. Every read and write hits the Redis first, and then it gets flushed to the real database afterwards, asynchronously through Kafka. That's interesting because it means that the thing preventing overselling is the in the critical moment isn't Postgres or Cockroach database at all. It's Redis. And here's exactly how. This is the Lua script running inside Redis. I didn't expect this level of detail, but let me walk through what it actually does. So the step one is it checks if this exact transaction ID has already been processed. That's idempotency. So if a request accidentally gets sent twice, like from a retry, it doesn't double charge the stock. Step two, it reads the current stock count, and step 3 is where the atomic part happens. It only decrements if the current stock is greater than or equal to what's being requested, and the check and the decrement happen inside the same script on the same call with no gaps in between. Redis runs this whole script as a single indivisible operation. That's not just similar to an atomic update, it's actually more airtight than what I actually guessed, because a single SQL statement can be affected by data replication lag, but a single threaded Lua script Redis genuinely cannot be interrupted the halfway through. And look at this part, the client gets their HTTP 200 back the moment the Redis script is succeeded, before the actual database has been touched at all. The real database update happens later through a background worker consuming from Kafka. That's the same read fast, write later pattern that I saw in the pastebin video, except here it's protecting real money, not just a link. So compared to my original guess, I said probably an atomic decrement as the database level. It went a step further and moved that atomic operation into Redis instead. specifically because it's faster and genuinely cannot be interrupted mid-operation. That's a stronger answer than what I had predicted, and it's honestly a great example of why generating a real design beats just reasoning about it in your head. I wouldn't have thought to push that atomic guarantee out of database entirely. That is a good suggestion by Maraya and a good generation by it. Here we can see the structure too. It's not very deep. The main logic lies here from steps 10 to 20, the main stock decrement logic. So I will also be making a video future on contributing to open source. I don't know in which project exactly, but a video is going to come soon. So make sure you tune in for that.